Do you want to run open source large language model locally? Then this video is for you. I have been sharing few videos related to open source LLM RAG and LangChain. And in the previous video, we deployed a Streamlit application where you can talk with any PDF. I observed one feedback from community is that we are using HuggingFace Hub in most of the cases. Are there any alternative where we can use open source LLM RAG locally? There was one option that is HuggingFace pipeline, but you can't load model locally if you don't have that much of GPU access. Then I came across to a library called Ollama. Ollama helps you run a large language model locally. In order to get started, you can just click on download based on your OS that you are using. And once the installation is completed, you need to pick which model you want to run. And before you can run any model, you need to pull that particular model so that it can download in your model libraries. So there is a model library on Ollama website. I will link all the links in the description. I'll also include how you can download Ollama and what are the models library it supports. As you can see, it has support to Gemma, which is latest lightweight model developed by Google DeepMind. It also has Llama, which is a LLM model by Meta. It also has Zephyr. So if you have been following my video series, you know that I've used Zephyr quite a lot time. So you have Zephyr and you have tons of other model. It also supports Lava. So where is that Lava? Right, Lava is a multimodal. You can also use Lava. So there are tons of model that you can choose. Now, once you want to use any model, you can click on that model. And as you can see, this is how you can run it. Ollama run Gemma. But in order to run this statement, you first need to pull that image. So in order to pull those image, open your terminal and you need to write Ollama pull Gemma. So this is the command that you use to load any model that you need. Since I've already pulled Gemma model, I can directly use Ollama list. So once I run Ollama list, as you can see, it shows me two different models. One is Gemma and one more is Llama. So these are the two models which I've already pulled. In order to run Ollama, you just need to enter a command, Ollama run and your model name. In our case, I've used Llama 2 as the model name. And once you enter this particular command, it will give you an interface where you can enter your query. So my query was, tell me a joke on AI. It told, sure, ears and AI related joke for you. Why did the artificial intelligence go to therapy? Because it was feeling a little glitchy. So just like that, you can run whatever you need. There are two ways you can run this particular statement. The first one is you can run Ollama run your model name. You can enter multiple prompt. The second option is you can write Ollama run your model name space and your query. So these are the two ways that you can use it. But our main focus is not just to use Ollama in terminal. We also need to integrate Ollama with our RAG application. So let's quickly jump to the code. All right, so let's start with the code implementation. If you're new to this playlist series, I recommend you to watch previous 3 to 4 videos in this playlist so that you understand what is going on. We use two files. One is app.py, one more is ingest.py. In ingest.py, we take a data source, we create the chunk of the data source, and using embedding, we store our data as embeddings inside a vector database, which is ChromaDB. But the data, what I'm using is my GSOC proposal, which I submitted in 2023. So if you want to take part of Google Summer of Code, I have linked a playlist on how you can create your Google Summer of Code proposal. Do check that out video. It will give you a detailed understanding of how you need to create your proposal. I also demonstrated my proposal so that you can refer it and you can prepare your own. So I used that particular PDF and I created a vector database of it using the library, which is HuggingFace inference embedding. And this is the embedding model that I've used. And once you save this DB, let's start with the code of app.py. That is how you can perform retrieval, augmented, and generation, three different steps. Let's quickly get started by importing few statements. Let's use the ingest.py. From ingest.py, I need my vector database and embedding model. I will copy those. And then I also need my large language model. And in order to pick your large language model, you need LangChain community. From there, LLMs, Ollama, it should be capital O. And we need prompt template. In order to use prompt template, we use from LangChain dot prompts, import chat prompt template. Since we will integrate LangChain expression language, we also need from LangChain core dot runnables. I need to import runnable lambda, and one more is runnable pass through. The reason why I need runnable pass through is initially user will not give his query. The query will come once you integrate your chain. And during that time, if you want to pass your question, you just have to use runnable pass through. So let's proceed. We also need the structured format for our response. That's where we use LangChain dot schema, and I'll use str output parser. And in order to get our response very quick, we'll also use callbacks. And in order to use callbacks, there are two callback manager you have to use. One is your callback manager, and another is you need to use the streaming tool. LangChain dot callbacks dot streaming. It should be streaming std out, and from that you need to import streaming std out callback handler. All right, so these are the few import statement that we are supposed to use. The first two is we need to use it for retriever, and then Ollama and chat prompt template is used for augmentation and generation. And in order to use LangChain expression language, we use runnable lambda and runnable pass through. And in order to get structured format, we use str output parser. And callbacks is just to get our response a very fashionable and quicker manner. All right, so let's come back to ingest.py. I will copy my HF token. I'll copy the HF token, and I will also copy the embeddings of it. You can find all the links in the description, which is the source code of it. So I'll just copy the embeddings from the previous file, which is ingest.py. All right. So now if you look at Chroma, right, you are using from documents. Here you are providing chunks and embedding, and then using a persist directory. Since we already have persist directory, I will make use of this file. And in order to make use of it, let's use a variable vector db. Vector db equals to Chroma, just Chroma. And inside Chroma, you need to define your persist directory to be db, and you need to pass your embedding model as embedding function equals to embeddings. So this is how you define your vector database when you need to load your persist directory. Vector db equals to Chroma, and inside Chroma you need to define your persist directory directory path, and then you need to define your embedding function, which is your embeddings from HuggingFace inference API. Now comes the first part. The first part is your retriever. In the RAG, step 1, RAG. So in order to use retriever, you just have to create a variable retriever equals to vector db dot as retriever, and you can add a parameter which is search keyword arguments, where my k should be 2. So what I'm currently doing is I'm creating a vector database, and once I create a vector database, whenever there is a user query, how many relevant documents should I pass? That is my k value. So in order to define that, I'll just use vector db dot as retriever search keyword arguments k to be 2. And for each step, I will use a print statement. I'll write triggering the retriever. Now comes the second part. And in the second part, we need to use the augmented prompt. Augmented prompt, which is my step 2 in RAG. And you need to define your prompt. I'll define the template first. And I'll copy the template from my previous video, which we have done. All right, so I've copied my prompt from the previous video, which we have done. And the prompt is very simple. The user writes, you are an AI assistant that follows instruction extremely well. Please be truthful and give direct answers. Please tell I don't know if user query is not in the context. Keep in mind, you will lose the job if you answer out of context questions. Then you need to pass your context from retriever and user query. Remember, only return AI answer. So usually you can give this or you can skip it as well. Most of the time prompt is being included. So I'll remove this because Ollama doesn't add prompt in your response. And then you can add assistant. And once you have your template defined, you need to add this template inside your chat prompt template dot from templates. You just have to use this particular line of code. All right, so this step 2 is done. I'll also write a print statement here. Adding prompt dot. So now comes the third part, which is your generator. I'll just write running model Ollama. So this is your step 3 in RAG, which is your generator. Generator is nothing but your large language model generator, which will generate the response. And LLM equals to Ollama. Here you need to define the model that you are using. The model that we need to use is Llama 2. Model equals to Llama 2. And you also need to define the callback manager. Callback. Let me check if I've given the correct spelling. Callback manager. That's correct. And you need to define your callback manager. Inside this bracket, you need to add the list, and then you need to add streaming std output callback handler. So this is how you initialize your LLM model. Let me check if it is correct. Ollama model callback manager callback. Yeah, this is correct. Now we will define our Langchain expression language syntax. This is probably very simple. First is you need to define a chain. Inside your chain, you can open a square bracket, and inside this, you need to define your input variables. The input variables in our case is context and question. Why? It is enclosed inside a curly bracket. And in order to define that, you need to write both the variables as it is what you have used here. Context should be as it is, and you also need to use question. Whatever you are given inside your input variable, it should be as it is. Since I told you that initially we don't have any user query, so we just have to use pass. And in order to use that pass, we have a function called runnable pass through, and you need to call that function. Coming to the context part, context is your retriever. So you just have to use retriever dot with config. You need to write run name equals to docs. All right, so this is the syntax. Now you have defined your input variables, then you need to add your prompt. And after your prompt, you also need to define the LLM. And once you define the LLM, you also need to define your output structure parser. That's it. So once you define your chain, you need to execute this. All right. I'll just write AI response. And in order to fetch your AI response, you can just write query equals to what do I ask the query. So since it was related to GSOC, I'll ask what is the project goal. So this is my prompt, and I will just write print query dot, not query, chain dot invoke your query. That's it. So let me revise what we have done so far. We imported few statements, then we define our embedding model, then you add your vector database where you need to call the persist directory where our data is already indexed. And then you perform retrieval augmented generation. In retrieval, you use your vector database as the retriever. And then in step 2, you add your prompt template and define chat prompt template. In step 3, we need to initialize our generator, which is Ollama model. Inside Ollama, we are using Llama 2 model. Then you need to define the chain. You need to initially define your input variables, which is context and question. Then you need to add prompt, LLM, and str output parser in a structured format. Then you can execute this by adding chain.invoke query. So let's execute this particular query. Sometimes it takes around 30 seconds as well, and sometimes it might take around 2 to 3 minutes. Usually, this also depends on your infra because you're running your LLM locally. So based on that, it might be between 2 to 3 minutes. You can also host the using Docker image, but let's continue. Let's write Python app.py, and once we execute this, we'll come back again and we'll check the response. So as you can see, there is no error in my particular statement. We have triggering the retriever, adding prompt, running model Ollama AI response. And as you can see, the project goal as stated in the document is to understand and implement how CSV parsing works. It actually missed out 2 keywords, but it should be fine. You can also run multiple prompts. You can improve the prompt. And if you have seen my third video, we also integrated ensemble retriever, which is an advanced RAG technique. You can probably include that methodology in this code as well. So this is it from this particular video. The main purpose was to tell you how you can run your open source LLMs using Ollama, and it can be done locally. Thank you so much. And do make sure you subscribe to the channel, because I've seen most of you watch the video but don't subscribe. Make sure you subscribe and hit the bell icon so that I can share more videos related to LLMs and generative AI. Thank you so much.